convert this time frequency domain equation to the time domain equation, you get ft equal e to the power at ut. Okay, so ut is the unit step function. Okay, now if you assume zero initial condition for for zero initial condition ut equal 1, because why for zero initial condition ut is 1, why? Because you know that from time t equals 0 to time t for infinite, ut always remain 1. So you can write that ft equal to e to the power minus ut. You can write that ft equal e to the power minus at. That is what you can write. Okay, for zero initial condition, ft equal e to the power minus at. Okay, so after that, if you go to the next page, then you get ft equal e to the power minus at, and it has pole. Pole is s plus a, so s equal minus a. That is our pole, and we'll analyze three conditions here. First condition, a greater than 0. Okay, now for a greater than 0, if you put the value a greater than 0 in this function ft equal e to the power minus at, then you can write ft equal e to the power minus a is 1 and time t is 0 initial case. Here time t is 0, so e to the power minus 0 equal 1. So initial value equal 1. Okay, so after that, ft equal e to the power minus a is 1, assumed as 1, and plus 1, e to the power minus a means e to the power minus 1, and t is assumed as infinite. So there are lots of line you can see there, and e to the power minus infinite basically. So if you multiply infinite by minus 1, it will be infinite, minus infinite. So ft equal e to the power minus infinite, and you know that e to the power minus infinite equals 0. So from there you can see ft starts at time when time is 0, ft starts at 1 and it goes down, down, down. And then when time t is infinite, it's close to 0. So that is the case of stable system. So for stable system, the function output will reduce steadily, and at time t infinite equal infinite, the output will close to 0. So this is a stable system, and for the stable system, you know that we assumed a equal 1, so you can say that pole is minus a minus 1. So minus 1 is the negative value, so you can say that pole less than 0. So when the pole less than 0, system acts as a stable system. Now the for next case, if you look at the next case, a equals 0, that is the next case. So you can write ft equal e to the power minus a is 0, and t is, you can keep it t, because if t is 0, 0 will be multiplied by 0, that will be 0. And if t is infinite, if you multiply infinite with 0, still you will get 0. So it does not matter. So t, whatever the t is from 0 to infinite, t is the time, it starts at 0 and goes up to infinite. So whatever the value of t, that will be if you multiply that with 0, that will always give you the output 0. So e to the power 0 equal, e to the power 0 equal 1. So there is a mistake here, so you can correct that. So e to the power 0 equal 0 into t equal 1. So because e to the power 0 equal 1. So it will always remain at 1, state 1. I mean 1. So that's why it is called marginally stable. From the stability definition, we have seen earlier that marginally stable system does not decay or goes to infinite. It always remain at the same state. Okay, now if you come to the third condition, here you can see the third condition, a less than 0. So if a less than 0, in that case you have ft here, ft equal e to the power minus at. So e to the power minus a is minus 1 here. We assumed it is minus 1, but it can be anything less than 0. It does not have to be minus 1. So whatever. So if, for our simplicity, for the simplicity of the calculation, we assumed it as minus 1, and then minus minus 1 into t. So initially we assume t equals 0, and you know that minus into minus, that is plus, so plus 1 into t is 0. So it starts at 1 like before. So it starts at 1, and then ft, you can see here ft equal e to the power minus e to the power 1 into 9999. So that means we're going to the time t equal infinite. So because in our calculator we cannot put infinite, so that's why I have given here 999. There are lots of 9. So if you uh, take your calculator and press e to the power 999999999, and then if you get the result, you'll get that, yeah, math error. That means that is the infinite result we get. So we are going to start from 1, and it goes up, up, and it goes up to the infinite point. So when you goes time t equal infinite, so in that case it will goes up to the infinite point. So from this discussion we can assume that there is a general trend with the pole and the stability. So if the pole is in right half plane, the system is the unstable system. If the pole is in left half plane, then system acted as a stable system, and if the pole is 0, in that case system is the marginally stable system. That is the conclusion we can draw from
Sir, could
this
you give the PDF, sir?
question. Yes, definitely. I will give you PDF, no problem. Okay, so our conclusion from this discussion is that can you say what is the conclusion of this discussion, Ajit, Mr. Ajit, can you say what is the conclusion of our discussion? Okay, Rabbani, you can say.
Sir, if the A value is positive, then system is unstable, sir.
Okay, so
Positive
we
pole,
don't.
positive
Yeah.
pole
So,
is unstable, negative pole
mhm.
contributes stable system, and zero pole contribute marginal systems.
Okay, marginally stable system. Okay, that is the contribution of poles. Okay, so you got that. So now let's solve a problem related to that. So that is our first problem, and we have something here. What is this? Can you assume that? What is this? Gs equal s plus 2 by s square plus 4s plus 3. What is this?
So it's a function.
It
The
is the
transfer
transfer
function, sir.
function. Yes, it is the transfer function
Transfer
of a
function, yes, sir.
system. Yes, so you solve a system, and after solving, you got this transfer function. You know, the transfer function equal output by input, and transfer function represented by this GS. So that is the transfer function of a system. Now, if you make a middle term here in the denominator, you can get s square plus 4s plus 3. That is what you can write, s plus 3 into s plus 1. So it will be s plus 2 by s plus 3 into s plus 1. So from this transfer function, you can easily find zeros, how many zeros are there and how many poles are there. So you know how to get zeros, to get zeros. So what is the definition of zero? Zero is the value of s that makes transfer function zero. So you have to make numerator equal zero. Numerator, you have to put numerator equal zero, then you get the value of s, that is minus 2, so that is your 0. And from this system you can see we have two poles here, because it is the second order system, because we have square in the denominator. From here is square, you can see that. So s plus 3 equals 0, so you can write that s equal minus 3. Okay, s equal minus 3. Okay, so you got s equal minus 3 here. Okay, and s plus 1 equals 0. Okay, so s equal minus 3, that is my one pole, and then s plus 1 equals 0, s equal minus 1, that is another pole. And if you plot that in your S plane, so this is called S plane, you know that, I think, from our last discussion we already told that. So S plane. So why it is called S plane? Because in this plane, we only plot the value of S, the value of S, right? So we only plot the value of S. S is indicates that it is in the frequency domain. So we only plot the value of S in this plane. That's why it is called S plane. And poles and zeros are nothing but the S value. Poles and zero are nothing but the value of S. And in x-axis we have real axis is called real axis, and that is also the S value. And if you look at the y-axis, that is the imaginary or j omega axis, that is also for the S value. So that's why it is called S plane. So from our zero and poles output, you can see our zero is -2, and we have two poles, -3 and -1, and there is no imaginary part for this case. That's why in imaginary axis we don't have any pole and zeros. But if we look at the real axis, so you can see at -1 we have a pole. That's why we have a cross here at -1. You can see that cross. So we have a cross here at -1. We have a pole here, and we have another pole at -3. So that's why we have another cross at -3. So you can see that. So we have two poles here, at one pole at -3 and another pole at -1. And we have one zero here. So at -1, we have zero at -2. So you can see there is a zero sign here. That is a zero sign at -2. So because we have one zero here. So from this definition, from our earlier analysis of the poles, we can assume, what can you assume? It is going to be it is contributing to a stable system, or it is going to be unstable system from pole analysis. What can you
It's
say?
unstable, sir.
Why?
Sir, because a value is less than, yeah, 0, sir.
Yeah, why we're talking about a value? These are not a value.
Sir,
Forget about a values.
S.
Always think about the s value.
So S value is less than A.
Sir, then, sir, as it is, sir, left side in the, sir, S plane, then it should be, sir, stable, sir. Or
Yeah,
it
so
is,
it
sir,
should.
in the inside of the
Yes, so we
S.
have two poles. You can see here we have two poles, one at -3 and other pole at -1. So from that pole plot, we can assume that these two poles will be contribute to the stable system. So let's check that. If we if we draw this transfer function in the time domain, uh, what will be the curve of this transfer function in the time domain? So to plot that curve of this transfer function in the time domain, you need a mathematics that is called partial fraction expansion. So by this partial fraction expansion, we can convert it to this frequency domain transfer function to the time domain transfer function. So let's see how we can do that. So we have s plus 2 here and s plus 3 by s plus 1 in the denominator, and in numerator we have s plus 2. So according to the partial fraction expansion, you can write a by s plus 1 plus b by s plus 3. Then if you multiply by the denominator s plus 3 and s plus 1, both sides, then you get s plus 2 at the left hand side. And here you get, so s plus 1 will be cancelled, s plus 1, s plus 1 will be cancelled. So you get a into s plus 3. Here you get a b into s plus 1. Okay, is that clear? Okay, so I think it is clear, right? Okay, so after that,
Yes, sir.
we get s plus 2 here in the left side, and in right side you get as plus 3a plus ps plus b. So as plus 3a plus ps plus b. That is what you get in the right side, and left side you get s plus 2. Okay, from this equation you can write s plus 2 equal s plus 2s to the power 0. So you know that s to the power 0 equal 1. So if there is no s, you can write that s to the power 0, because s to the power 0 equal 1. You know that. So that's why you can write s to the power is 0 here. And this is s to the power 1. First of s is the s to the power 1. You know that. That's why we have a s here, because it is s to the power 1. So s plus 2, we can write s plus 2s to the power 0. Then we can write s term together here, ds as plus bs. So we can write that a plus b into s, as plus bs. We can write that a plus b into s. And then we have 3a plus b. We can write that 3a plus b into s to the power 0. So s to the power 0 equal 1, right? So that's why you can write 3a plus b into s to the power 0. So after that, so we have two terms, two power, or two types of power here. One is s to the power 1, other is s to the power 0. So this is s to the power 1. So we can combine s to the power 1 term together, and we can also combine s to the power 0 term together. So if you take the coefficient of s to the power 1 here in the left side, so it will be 1. And if you take the coefficient of s to the power 1 in the right side, it will be a plus b. So 1 equal a plus b. So you can write that b equal 1 minus a. Okay, that is equation number 1. B equal 1 minus a. Okay, so now if you go to the second term, s to the power 0, you can see here 2 s to the power 0 here in the left side, and right side we have 3a plus b s to the power 0. Okay, so you can write 2 here in the left side, and in the right side you can write 3a plus b s to the power 0. So that's why that is the coefficient 3a plus b s to the power 0. You should omit s to the power 0. So from the first equation, you can get here 1 equal a plus b. You can write that b equal 1 minus a. That is my equation number 1. And if you come to the second one, so you have 2 equal 3a plus 2b. So you can put the value of b here. So you can write b equal 2 minus 2 minus uh, okay, so from here, okay, they are putting the value of uh, a, putting the value of a here. So okay, so you can combine these together, right? So how the
Sir, how
yes.
it comes, sir? 1 is equal to a plus b and 2 is equal to 3a plus 2b.
Oh, from this okay, you can see here left side s to the power 1 term. We combined s to the power 1 term, all the s to the power 1 term left side, and all the s to the power 1 term in the right side. You got it?
Okay, sir. Okay, sir. Yes, yes.
Yeah, other one is s to the power 0. So we got then 1 here, 1 equal a plus b. I'm seeing whether its calculation is okay or not. Then b equal 1 minus a. Okay, first calculation, first one is okay. Then the second one, 2 equal 3a plus b. Okay, that is the problem here. Here is the 2, extra 2. There should be no 2, right? That's why I'm facing problem.
Yes, sir.
Yeah, so
Only b,
yeah,
sir.
there is a 2 here. Yeah, there should be no 2 here. Okay, so here is the b. You can see b equal 2 minus 3a, 2 minus 3a. So from there, the value of b equal 1 minus a. From the first equation, you can put that here, b equal 1 minus a. Okay, so after putting b equal 1 minus a, you get 2 minus 3a, then 2a equal 1. So a equal half, right? That is my first value. So a equal half. Now, from this equation, equation number 1, you can see that b equal 1 minus a, b equal 1 minus a. So you can put that 1 minus a. So 1 minus half, b equal 1 minus half. So if you put that, so you get half. So here you get half in b equal half and a equal also half. Okay, good. So after that, you want to put the value of a and b from our initial equation. The initial equation you can see here, s plus 2 by s plus 3 into s plus 1 equal a by s plus a plus b by s plus a by s plus 1 plus b by s plus 3. So it should be half by s plus 1 plus half by s plus 3. Okay. Okay.
Yes, sir.
Okay, so here we can write that. So s plus 2 by s square plus 4s plus 3 equal half by s plus a, s plus 1 plus half by s plus 3. Now, what you, so this is the frequency domain. This is still in frequency domain. What we like to do, we like to convert this frequency domain form to the time domain form. So if you want to convert this frequency domain form to the time domain form, the first term here, half by s plus 1, you can write that half and 1 by s plus a. What can you write for that? 1 by s plus 1.
So e to the power
E to the power
minus t,
minus
sir.
t.
Yes, so that is what you should remember from chapter 2. So that is what you can write. So 1 half e to the power minus t. Then here also you can write half e to the power minus 3t. So this is the 3t minus 3t, and this is the minus t. So one is minus t and one is minus 3t. Now we want to plot this. This is in time domain now. So we want to plot this function in our x y axis. Okay, so how can we get that? So you can see here the plotting here. So you can see, and the magnitude is half, so it will start at half. So it started at half, and then e to the minus t. So minus t means it will decay with time. You already know that. So minus t means it will decay with time. So e to the power minus t and e to the power minus 3t, which one will decay faster?
Sir, minus ct, sir.
Yes.
No, sir. No,
So
sir.
yes, you are right. So coefficient 3
Okay, sir.
is greater than coefficient 1. And minus does not count because minus means decay. Minus 3 is less than minus 1. That is okay. But minus,
Yes, sir.
if you minus means decay, minus does not, I mean, it will not count it the value. It will not count it with the value. So minus means decay. So it will decay. And which one will decay faster? The higher coefficient will decay faster. So 3 will be decay faster than the 1. So that's why you can see here the 3 half e to the power minus 3, so this will decay faster. This will decay faster with time. And the second one is it will also start with half, the first one, but it will decay slightly slower than the e to the minus 3t. So ultimately, both will decay to 0, close to 0 when time goes to infinite. So like this. So you can see, so e to the minus 3t, e to the minus 3t, half e to the minus 3t. This is the curve for that. This is not the exact curve. If you want to get the exact curve, you can also get that by assuming the time t equals 0, t equal 1, t equal 2, t equal 3, t equal 4, 5, 6, 7, 8, 110, something like that. So you have to assume the time up to infinite. So if you put time t equal infinite, then it will be 0, definitely. Yeah, the time t equal infinite, it will be definitely 0. And for, so you have to assume time here. So we have time here and time here, and other terms are fixed. You can see half is fixed, e to the power is fixed. Only you have to assume the time. So you can see here, so if you add these two together, you get 1. So half plus half equal 1. So it will start from 1. And you can see it will, this one is the total signal, half e to the minus 3t plus half e to the minus t plus half e to the minus 3t. That is the total one. So that is the output of the total
Sir,
signal. Yes.
sir, f of t 0 and কি ইজ ইনফিনিট এই জিনিসটা একটু আবার একটু বলেন স্যার, বুঝতে পারিনি।
Oh, it means the function will goes to 0 as time goes to infinite. So suppose if you put infinite time here, time t equal infinite, and you put time t equal infinite here. So e to the power minus infinite equal 0, right? You know that? E to the power minus infinite equal 0. So both term
Yes,
will
sir.
goes to 0. So ultimately, that is what it said. So as ft goes to 0, as time goes to infinite. মানে সময়ের সাথে সাথে টাইম এর সাথে সাথে ফাংশনটা হচ্ছে 0 এর দিকে চলে যাবে। So ft goes to infinite as time goes to 0. So that's why it is said that it is a stable system. You can see. So that's why it is said it is a stable system, because the function, the value of function will be reduced to 0 when time goes to infinite. So it will not goes to 0 actually. So because the time you have to go up to infinite time, then it will be 0. But actually we're not going to the infinite time. But it is not 0, but it will goes to 0 if you go up to infinite time. That is our assumption. Okay, so you got it right. So from this curve, you can say the system acts as a stable system. And from your pole zero plot, you already assume that in frequency domain. So in frequency, domain, it is very easy to assume, right? Okay, so in
Yes, sir.
frequency domain, you can see, you can find it very easily, but in time domain, you have to have get some work to get that. So you have to plot it in time domain function, then you get that the system is actually stable system. Okay. Okay, so that is for poles and zeros. So real. I mean, the real axis poles and zeros. What about imaginary poles and zeros? So imaginary poles and zeros. So let's talk about imaginary poles and zeros. So imaginary. Okay, we're not talking about zero. We are talking about only poles. So imaginary poles and stability. So the second problem. The first problem, you have only real poles. You can see, because imaginary axis, there is no value. For the first problem, you can see here only real pole, s equal minus 3, and other one is s equal minus 1. Okay, so these are the real poles. So s equal minus 3 and s equal minus 1 for the first problem. Now, if we get imaginary pole, how can we solve that? So let's go and check that in the second problem. Okay, here we have imaginary poles and stability problem. So gs equal s plus 1 by s square plus 2s plus 2. S plus 1 by s square plus 2s2. Okay, so you can see here, so the denominator, by solving the denominator, we always get the pole, and by solving the numerator, we always get the 0. So from this, you can see that 0 is s plus 1 equal 0. So that means s equal minus 1. So that is my 0. Very easy to get. But for poles, you can see we have to apply the formula we have learned for second order equation. S12 equal minus b plus minus root over b square minus 4ac by twice a, because we have imaginary pole right now and middle term is not possible. So we cannot just simply middle term it. So minus b, what is b here? So b is 2. You can see that from the denominator term here. We are solving this one. S square plus 2s plus 2 equals 0. We assume that s square plus 2s plus 2 equals 0, because that is we, by solving the denominator, we can get the pole. That's why we assume that. Okay, so now we are solving that. So p equal s12, that means pole equal 2 poles. That's why we're writing s12 here. and minus b plus minus root over b square minus 4ac by 2ac. So minus 2, you can see that. So then plus minus root over b square is 4 minus 4ac. A is 1. A is the coefficient of ac square, you know that. So a is 1 here. And c, what is c here? C will be, yeah, c will be 2 here. This is c. What we have written here? 2. It does not seem to 2. It should be 2. Okay, so minus v. So if you solve that, so you can get minus 2 plus minus root over minus 4. Minus 2 plus minus root over minus 4. That is what we get in the numerator. And in denominator, you get 2. So you can write that. So this 2 to cancel, you can take 2 common here, and then you get minus 1 plus minus j1. Okay. So how many poles we have here? How many
Two
poles we
poles, sir.
have here? 2 poles. What are those? What are the values of those poles?
Sir, minus 1 plus
The plus is
1
J1,
I.
minus is J1.
Yes, so we
Minus.
got 2 poles here. One is minus 1, minus 1 plus j1. No, one is minus 1 plus j1, and other is minus 1 minus j1. So 2 poles. So let's plot it in our S plane. So this is my S plane. So x-axis is my real axis and y-axis is my imaginary axis. Right, so real axis and imaginary axis, we got it. Then we want to plot the 2 poles. You can see here, first pole is minus 1, so you have to go to minus 1. We come here at minus 1, and then plus j1. So this is the plus j1. So minus 1 plus j1, that means one pole is here, and other pole is minus 1 minus j1. So you can see other pole is here, minus 1 minus j1. So one very nice and important thing you can observe from here, that these 2 poles are the mirror of each other. These 2 poles are the mirror of each other. You
Yes, sir.
understand that? Okay, so
Yes, sir.
imaginary poles, if your system has imaginary poles, those poles will always stay at the mirror with each other. That means if you put a mirror here at the x-axis, if you put a mirror, if you put a mirror there in the x-axis, you will get the reflection of one pole to the other side. Those are the mirror with one another. So always remember that. So imaginary pole, if you have imaginary pole, they always come together. They always come together as the mirror of one another. So if one pole is plus 1 and minus 1 plus j1, other pole must be minus 1 minus j1, because they are the mirror of each other. Okay. Now, okay, so we have imaginary pole, but we know that from our stability definition, both the pole at negative axis, we have also a 0 here, 0 at minus 1. You can see that. So we have a 0 at minus 1. Now, from our stability definition, we know that as the poles are negative, we can assume that the system is somewhat stable. Let's verify it from our time domain representation. So stability verification in time domain. So to get the time domain verification, what you have to do, you have to convert your frequency domain transfer function, it's given here. So your frequency domain transfer function to the time domain transfer function to get the what will be the curve of this transfer function in the time domain. Okay, so what you have to do, you have to inverse Laplace for that. So inverse Laplace, we know that. So here is it. We have a formula here. So we know that inverse Laplace of s plus alpha by s plus alpha square plus omega square equal e to the power minus alpha t cos omega t ut. That is the formula. So what is the formula? Inverse Laplace of s plus alpha s plus by s plus alpha square plus omega square would equal, we know that e to the power minus alpha t cos omega t. If there is no alpha, you already know that s by s square plus omega square, then it is cos omega t, right? So s by s square plus omega square cos omega t. But if there is alpha, s plus alpha by s plus alpha square plus omega square, then e to the power alpha t plus into cos omega t. Cos omega t. And ut will be always there because we know that ut is the unit step function. It always remain with the other function. So, and for zero initial condition, you know that ut is one. So that is the plot of ut. For zero initial condition, ut is one. So you can prove the value of ut is one because we only assume time t equals 0 to infinite. We don't assume negative time. Okay. So we get e to the minus alpha t cos omega t. So inverse Laplace of s plus alpha by s plus alpha square plus omega square equal e to the power alpha t e to the minus alpha t cos omega t. That is the formula. Now we want to apply this formula in our transfer function. Okay, so let's apply that. So this is my transfer function here. This is my transfer function here, and we want to apply that formula here. So we can write s plus alpha. So this is like s plus alpha, s plus alpha, s plus 1 equal s plus alpha. Then we have denominator s plus alpha square plus omega square. How can we do that? So we have s square. We can write that s square. Then 2 alpha. Okay, so if you write that s plus alpha square, so s plus alpha square equal 2 alpha s So we have, okay, so s plus 1 here and s square plus, okay, so s plus alpha square. So we can write that s square plus 2 alpha as plus s square plus 2 alpha s plus alpha square, right? So s plus alpha square equal what? S plus alpha square equal s square plus 2 alpha s plus alpha square. Is that okay?
Yes, sir. Yes, sir.
And in numerator, we have s plus alpha. We put that s plus alpha here. And in denominator, we have s plus alpha square. We can write that s square plus 2 alpha s plus alpha square. And we have also omega square. We can write that omega square. Now, this is the formula. And this formula will output e to the minus alpha t cos omega t. That is my output from that given formula. But okay, now we will compare with this function with our original transfer function. This is the original transfer function. So if we compare this together, you can see s plus alpha. So alpha equal 1. Can you get that? Alpha equal 1 from here.
Yes, sir. One, sir.
Okay, so good. So we got alpha equal 1. Now, if you compare the denominator, we have s squared the first term here also.
Is also equal.
S square. Now 2 alpha s, here we have 2s. So you can see here 2 alpha s equal 2s. So alpha equal 1. Is that clear? Okay. Then alpha
Clear,
square plus omega square, the last term, and we have 2 here. Alpha square plus omega square equal 2. We can write that. So 2 equal alpha square plus omega square. And 2 equal alpha square equal, already know that alpha is 1, so alpha square equal 1 square and omega square is there. So you can write that omega square equal 1. So you know that omega will be 1. So omega equal 1. Okay. So if the omega is 1 and also alpha is 1, so you can get from this formula e to the power minus alpha t cos omega t, then e to the power minus alpha t equal e to the power minus 1t, that means e to the power t, and cos omega t means cos 1t cos t, e to the power minus t cos t. That means for this transfer function, what will be the time domain representation? E to the power minus t cos t. So what you get here, that is what you get, ft equal e to the power minus alpha t, alpha is 1, e to the cos omega t, cos omega is also 1, so you can write e to the power t minus t cos t. Is that clear?
Yes, sir.
Okay, good. So now we already know the system is stable because the pole is in negative axis, negative left of side. Okay, let's see how we can get that. So you can see here the magnitude is 1. There is nothing. That means we have 1 magnitude. So we start from time 0 equal 1. 1. Okay. So as time at time 0 it is 1 because you know that cos 0 equal 1. Cos 0 equal 1, e to the power minus t, e to the power minus 0 equal 1. So it will be started at 1. Yeah, so t equals 0. So for t equals 0, it will be 1 because cos 0 equal 1, and e to the power minus t, e to the power minus 0 equal 1, and the magnitude is 1, so it will start at 1. Now, e to the minus t, you can see here e to the minus t, so e to the minus infinity equals 0, you know that. So e to the minus infinity equals 0. E to the minus infinity equals 0. So e to the minus infinity equals 0, you know that. So that means what will
ft
happen
equal
here?
to 0, sir.
Yeah, so it will decay with time. So time goes up, it will down, it will decay, and it will come here.
Stable, sir.
Yeah, and as you can see that it is the imaginary pole. We have imaginary pole always make mirror image with one another. So that means you'll get the mirror of this in the, if you put a mirror here, you'll get the reflection of that here, right? So we are getting a reflection here. Can you see? We are getting a reflection here. So because the imaginary poles, there will be always a mirror. So that's why we're getting a reflection here. Then this is our boundary, and cos omega, you know that cos t always starts from 1. So then it goes to -1, and it cannot cross the boundary. So cos will decay also with time. So it will oscillate between the boundary, two boundary, positive pole and negative pole. So
Sir,
that
reflection ta konta? Sir, reflection ta?
this one is the reflection. Okay.
Sir, negative part sir reflection
হয়ে
sir.
যাবে না?
Yeah. So this is for
Sir, এটা
positive
তো
poles.
stable হয়ে যাওয়ার কথা sir.
Yeah, this is for positive poles, and this is for negative -1 plus j1 poles. So that is the reflection of the positive pole. Yeah, it is stable because it goes to 0. It goes to 0. Okay.
আপনি তো জিরো করতেছেন না স্যার, এই যে জিরো হইছে।
Yeah, it will goes to 0 time t. Ultimately, it is not 0 because time t equal infinite. We cannot go to time t equal infinite. Is that clear?
Yes, sir.
And if you get something like that, suppose if you get something like that, then it will also get the reflection like that. Okay, understand my point? Suppose you get something like that, then in positive, then you get the reflection. Okay. Okay, so system response.
No more to the sir.
Sir, no more today, sir.
স্যার
স্যার
Okay, so
আর
this is
আপনার কাছে সময়ও নাই বেশি,
সময়ও
10
নাই,
মিনিট
স্যার।
আছে।
yeah. Okay, so this is a new topic, so we'll start tomorrow,
নেক্সট ক্লাস ইনশাআল্লাহ।
inshallah. Okay, so we'll share the here. What?
স্যার
Yes.
বড় ভাইরা যারা চলে গেছে স্যার ভার্সিটি থেকে গ্রাজুয়েট হয়ে, তারা কি ইঞ্জিনিয়ার লাগাইতে পারবে নামের সাথে, নাকি শুধু আমরাই পারবো স্যার?
পারবে, কিন্তু ওই যে কি যেন ফিজিক্স কেমিস্ট্রি রিকোয়ারমেন্ট যারা ফুলফিল করে না তারা মনে হয় পারবে না।
ফিজিক্স কেমিস্ট্রিটা কি স্যার?
ওই যে ফিজিক্স কেমিস্ট্রি গুলো নিয়েছেন, ইঞ্জিনিয়ারিং ফিজিক্স কেমিস্ট্রি যেগুলো ছিল,
যারা ডিপ্লোমা করছে ওদের স্যার ইয়া দিচ্ছে, ওয়েবার দিচ্ছে স্যার।
তারা তো লাগাতে পারবে না।
ইয়েস স্যার।
মানে আমরা পারবো স্যার, আমরা তো করছি সব ফিজিক্স কেমিস্ট্রি ফিলোসফি সাইকোলজি সব।
ডিপ্লোমা করে না যাই করেন, ফিজিক্স কেমিস্ট্রি করা লাগবে।